Let's jump right into this explainer on modernizing fleet data architecture. Look, what we're talking about today isn't just some standard IT upgrade. It's a complete, fundamental shift in how we ingest and actually monetize enterprise fleet data. If you're leading technology for a modern fleet, whether you're a CTO or an enterprise architect, you already know the data revolution is here. But let's be honest, your underlying infrastructure is probably feeling the strain, right?
So here's our game plan. We're going to cover the enterprise scalability crisis, look at some architectural blueprints, map out the enterprise telematics data, and finally get into the financial impact and business cases.
Let's kick things off with part 1, the enterprise scalability crisis.
We really need to reframe how we view our assets. Drive any modern fleet vehicle down the highway today, and you're not just moving cargo anymore. You're effectively operating a highly sophisticated mobile data center. And the scale of what these mobile data centers produce, it's just staggering. A single vehicle easily generates over 500 data points every second. So you scale that up to a 1,000-vehicle fleet, and you're streaming a massive 500,000 metrics every single second. Just pause and think about that scale for a moment. We're talking GPS coordinates, OBD-II engine diagnostics, AI dashcam metadata, and ADAS systems, all firing off simultaneously.
And honestly, this is exactly where the system breaks. Traditional legacy RDBMS solutions, your PostgreSQL or MySQL setups, and even generic NoSQL databases, they just buckle under this kind of velocity. They were built for discrete transactions and moderate query loads, definitely not for continuous high-frequency ingestion. When you try to force 500,000 metrics a second into a relational schema, what happens? You get severe write amplification, massive index bloat, and lock contention bottlenecks. Basically, your queries slow down to an unmanageable crawl.
Which forces a massive strategic dilemma for us in enterprise architecture. Because your infrastructure can't handle the sheer volume of data, you're forced to make a really tough choice. Do you absorb the astronomical, infinite costs of scaling your storage, or do you start deleting historical data? And we all know, if you delete that data, you're actively destroying the long-term predictive models your entire business relies on for things like predictive maintenance and fuel optimization. It's a lose-lose situation.
All right, moving on to part 2. Architectural blueprints, specifically edge-to-cloud integration.
Let's look at how we solve that exact storage dilemma by addressing the data at the point of ingestion, way before it ever hits the cloud. It all starts with edge intelligence. The Telematics Control Unit, or TCU, sits right in the vehicle's backbone and handles crucial edge pre-aggregation. So instead of blasting raw 100 Hz sensor bursts over a cellular network, it actually downsamples that data locally to 0.2 Hz, which is roughly one sample every 5 seconds. It also handles offline retention for disconnected states, and crucially, it uses an event-driven push protocol, meaning if there's a real-time safety trigger, like say a collision warning, it completely bypasses the batching and sends out alert immediately.
But to handle all that structured, pre-aggregated data once it finally lands in the cloud, you absolutely need a specialized time series core. This is where InfluxDB comes into play. Unlike traditional databases that kind of treat all data equally and just choke on complex secondary indexes, a time series core is natively built from the ground up for time-windowed aggregations and extremely high-velocity ingestion.
When we're talking at the enterprise level, InfluxDB gives us some massive structural advantages. First off, its tag versus field indexing manages tag cardinality brilliantly by separating metadata from the actual metrics. Second, its columnar compression leverages the predictable patterns in time series data to give you an 80 to 90% reduction in your storage footprint. That's huge. Combine that with automated downsampling retention policies, where, for instance, your 30-day raw data is automatically summarized into long-term hourly rollups, and suddenly you can handle millions of writes per second without any locking, all while keeping your storage costs entirely predictable.
Let's shift gears to part 3, enterprise telematics data mapping.
So how do we actually organize this operational chaos? Well, your fleet data isn't just voluminous, it's incredibly heterogeneous. This architecture seamlessly manages a multi-source ingestion strategy, handling 11 completely different telematics streams. You've got high-frequency numerical data like tire pressure and battery voltage, you've got event-driven alerts like harsh braking, and then you have metadata coming in from AI dashcams. InfluxDB ingests all of this, and the best part? It does it without the rigid schema nightmares you'd get with a relational database, giving you a single, unified source of truth for your entire fleet.
Now here is the absolute game changer, low latency correlation. Because all of this diverse data is precisely timestamped within a unified layer, InfluxDB can execute sub-second alerting mechanisms for risk mitigation. For example, it can actually cross-correlate driver monitoring system fatigue scores with ADAS collision warnings and proximity sensor data in under 500 milliseconds, less than half a second.
That gives your dispatchers the exact time they need to proactively radio a driver before an incident even occurs, rather than finding out about a crash minutes later.
Finally, let's look at Part 4, Financial Impact, TCO, and Business Cases.
Enterprise architecture is ultimately about business value, right? Great tech is only great if it delivers undeniable ROI. And the financial reality here is pretty hard to argue with when you look at real-world deployments. Take a national delivery service operating over 1,000 vehicles. By solving their database bottlenecks, they hit a payback period of just 2.4 months. That yielded $4.68 million in net annual savings. Or consider a long-haul trucking firm with 500 vehicles. By focusing on predictive maintenance and safety, they saw an incredibly aggressive payback period of just 1.7 months, driving $2.34 million in direct savings.
When we look at the bottom line ROI that's typical across these kinds of enterprise deployments, we're seeing massive, measurable operational outcomes. We're talking about a 30% reduction in accidents, largely thanks to that sub-second correlation and alerting we just talked about. We're seeing up to 15% fuel efficiency gains by accurately tracking consumption anomalies and preventing theft. And we're seeing a 25% reduction in maintenance costs because you finally have the historical data retention you need to power truly accurate predictive maintenance models. It completely solves that strategic dilemma we discussed earlier.
So, I'll leave you with this final thought regarding your own infrastructure's readiness and operational resilience. Is your legacy database architecture actually prepared to handle the incoming, exponential growth of telematics data? Or is your predictive intelligence already being bottlenecked by index bloat and out-of-control storage costs? Look, reevaluating your time series core isn't just another IT task to put on the backlog. It's an absolute strategic imperative to unlock millions in operational savings. Thanks for joining me for this explainer.